We now discuss the second case of integrals involving rational functions solved by partial fractions. The second case is all about linear factors that are repeated. So for each linear factor ax plus b that is repeated k times as factor in the denominator of a proper rational function, there corresponds k partial fractions of the form a sub 1 over ax plus b plus a sub 2 all over ax plus b quantity squared plus a sub 3 over ax plus b cubed plus and so on and so forth plus a sub k all over ax plus b raised to k, where a1, a2, and a3 up to ak are constants to be determined. So, if the linear factor ax plus b, there is one partial fraction a over ax plus b. Once it is repeated, there will be an additional partial fraction whose denominator ax plus b is raised to the power of 2. If it is repeated 3 times, then there will be an additional partial fraction and the linear factor ax plus b will be raised to the power of 3. So, the number of partial fractions corresponding to a linear factor ax plus b raised to k will be k partial fractions. So, we have to calculate for the values of a1, a2 up to a sub k. If, for example, you have a linear factor 3x plus 5 raised to the power of 4 as factor in the denominator of the rational function, then there will be 4 partial fractions corresponding to this linear factor that is repeated 4 times. So let us have an example. We integrate 2x minus 1 quantity dx all over x times x plus 2 squared. So see that the denominator is already in the factored form and it is a proper rational function because the degree of the numerator is 1. This is of degree 1 and the denominator is of degree 3. So it's a proper rational function. So since the denominator is already given in the factored form, let us isolate the integrand. (2x minus 1 all over x plus 2 squared). The denominator is comprised of two linear factors. One is distinct, that is x, and the other one, x plus 2, is repeated. So all in all, there will be 3 partial fractions corresponding to this integrand. One partial fraction for the linear factor x plus another for the linear factor x plus 2, and since it is raised to the power of 2, there will be an additional partial fraction c over x plus 2 squared. Right? So just like what we did in case 1, we combine the fraction at the left. We'll be getting a times x plus 2 squared plus b x plus 2 plus c x all over x plus 2 squared. So in here, we can cancel both denominators. So the least common denominator is x times x plus 2 squared divided by x gives us x plus 2 quantity squared times a. LCD divided by x plus 2 is x plus 2 times b. LCD of x times x plus 2 squared divided by x plus 2 squared gives us x times c. And that is equal to 2x minus 1. Okay, so we solve for a, b, and c by substituting appropriate values to x. So say x is equal to 0. So 2 times 0 minus 1 is negative 1. All x's at the right side will become 0. So bx, x plus 2 is 0. Cx likewise will be 0. So that leaves a times 0 plus 2 squared. So 0 and 2 is 2 squared is 4a. So we get the value of a equal to negative 1/4. Let us say that x is negative 2 to make the factor x plus 2 0. So we substitute negative 2 to x. 2 times negative 2 is negative 4. And negative 1, that will be negative 5. So terms with x plus 2 will become 0. So c times negative 2 is negative 2c. That gives us the value of c equal to positive 5 halves. Okay? Now, we still have to calculate for the value of b. And there will be no other value for x that will directly give us the value of b. So at this point, we can use any value to solve for b. We substitute x equal to, say, negative 1. So 2 times negative 1 minus 1 is negative 3. Negative 1 plus 2 is positive 1 squared is 1 times a. b times negative 1 is negative b times negative 1 plus 2 is positive 1. So b times negative 1 times positive 1 is negative b. And then c times negative 1 is negative c. But since we already have the values of a and c, we can substitute these values to negative 3 equal to a minus b minus c. Thus, we have negative 3 equal to a, negative 1/4 minus b minus c, which is 5 halves. So negative 3, then negative 1/4 becomes positive 1/4. Negative 5 halves becomes positive 5 halves equal to negative b. So that will be negative 12 plus, okay, so the least common denominator here I think is 4. So yes, negative 12 plus 1 plus 10 all over 2 is negative b. So negative 12, 10, and 1 is negative 1/2. Is that correct? Let me see, Negative 3 times 4 is negative 12 plus 1 plus 10. Okay, so negative 12 plus 11 is negative 1/2, and then our b will be positive 1/2. Now, I need to check this. X is negative 1, so negative 3, negative 1, a, that will be negative 1, b, negative c. A is negative 1/4, b, negative b, and c is negative 5 halves. Negative 3 plus 1/4 plus 5 halves. 4, negative 12 plus 1, 10, negative b. Oh, the denominator should be 4. Okay, sorry about that. There. Equal to negative b. So that will be negative 1/4 equal to negative b. So b is positive 1/4. Okay. So we shall now write our integral as a 1/4 over x negative 1/4, that is, and then b is 1/4 over x plus 2, and c is 5 halves over x plus 2 squared. Quantity dx. So we integrate negative 1/4 dx over x. That will be negative 1/4 ln absolute value of x plus 1/4 dx over x plus 2 is ln absolute value of x plus 2 plus 5 halves. In this case, it's no longer of the form du over u, but du over u squared. So we use the power formula. That becomes x plus 2 raised to negative 2 plus 1 is negative 1 over negative 1 plus c. So let us combine the two ln's. That will be 1/4 ln of, since it's the difference, that will be equivalent to the ln of the quotient. So x plus 2 over x. And then minus 5 all over 2 x plus 2 plus c. Okay. Another example. We integrate x squared minus 2x minus 3 all over x minus 1 squared x plus 2 squared. Okay, quantity dx. Once again, let us disintegrate this or break this down into several partial fractions. X squared minus 2x minus 3 all over. The denominator is already given in the factored form. So both factors are linear and both are repeated. So a over x minus 1 plus b over x minus 1 squared plus, we go now to the factor x plus 2, so c over x plus 2 plus another one, d over x plus 2 squared. Okay, so the right side will have the same least common denominator as the left side, so they will cancel, and combining the fractions, the numerator will be a x minus 1 x plus 2 squared plus b x plus 2 squared plus c x plus 2 or x minus 1 squared, x minus 1 squared x plus 2, and then plus d x minus 1 squared. Okay, that should equal x squared minus 2x minus 3. So say we now solve for a, b, c, and d. Say x is equal to, start with 1. So we have 1 minus 2 minus 3. That will be negative 4 equal to, all factors x minus 1 will be 0. So b times 1 plus 2 squared. 1 plus 2 is 3 squared is 9. So 9b. Our b is negative 4 over 9. Okay, next. Say x is equal to negative 2. Purpose is to make x plus 2 0. So negative 2 squared is 4. Negative 2 times negative 2 is positive 4 minus 3. So 4 and 4 minus 3, that would be 5. Okay, and then all x plus 2 will be 0. So negative 2 minus 1 is negative 3 squared is 9d. So d is 5 all over 9. Okay, no more values for x that will give us directly the values of a and c. So we can assign any value and make use of the values of b and d. So say x is equal to 0. So 0 squared minus 2 times 0 minus 3 is negative 3. 0, a times 0 minus 1 is negative 1. And then negative 1 plus 2 is positive 1. Squared is 1. So a times negative 1 times 1 is negative a. Now for b, negative 1 plus or 0 plus 2 is 2. Squared is 4b. So plus 4b. Wait, huh? I think I committed a mistake there. Again, when x is 0, 0 times negative 1, or 0 minus 1 is negative 1. 0 plus 2 is 2 squared is 4. So that should be negative 4a. Negative 4a. And then 0 plus 2 is 2 squared is 4, so that will be 4b. 0 minus 1 is negative 1, squared is positive 1. 0 plus 2 is 2, so 1 times 2 is 2c. Finally, 0 minus 1 is negative 1, squared is positive 1b. So plus d. Right? So negative 3, we substitute the values of b and d. For a, 4 times negative 4 over 9 is negative 16 over 9, plus 2c, plus d is 5 over 9. So this becomes what? Negative 3. Negative 16 over 9 plus 5 over 9 is negative 11 over 9. To the left is positive 11 over 9 equal to negative 4a plus 2c. So negative 3 times 9 is negative 27, and 11, that will be negative 16 over 9 equal to negative 4a plus 2c. Or negative 8 over 9 equal to negative 2a plus c. So we now have an equation involving a and c. Let us call it as 1. Okay, so let us continue here. We now substitute negative 1. No? Say x equal to negative 1. So negative 1 squared is 1. Negative 2 times negative 1 is positive 2 minus 3. That will give us 1 plus 2 minus 3 or 0. So the left side is 0. Next, negative 1 minus 1 is negative 2. Negative 1 plus 2 is positive 1. Squared is 1. So that will be negative 2a. Next, negative 1 plus 2 is positive 1. Squared is positive 1b. Then, negative 1 minus 1 is negative 2. Squared is 4. Negative 1 plus 2 is 1. 4 times 1 times c is 4c. And negative 1 minus 1 is negative 2 squared is positive 4b. So we substitute the values of b and d. 0 equal to negative 2a. B is negative 4 over 9 plus 4C. 4 times 5 over 9 is 20 over 9. So negative 4 over 9 plus 20 over 9 is 16 over 9 to the left. Negative 16 over 9 equal to negative 2a plus 4c. Okay, we call it as equation 2. So between 1 and 2, we can eliminate a by subtracting 1 from 2. Okay? So equation 2 minus equation 1. Negative 16 over 9 minus negative 8 over 9 gives us negative 8 over 9. Negative 16 plus 8. No? Negative 16 minus negative 8. That is equivalent to negative 16 plus 8. So negative 8 over 9 equal to negative 2a minus negative 2a. That will eliminate a. 4 minus 1c. That will be 3c. So your c here is negative 8 over 27. So if c is 8 over 27, substitute it to 1, negative 8 over 9, negative 8 over 9 equal to negative 2a plus c, negative 8 over 27. So negative 8 over 9 plus 8 over 27 equal to negative 2a. Negative 2a. So negative 27 plus 8. Negative 27 plus 8 is negative 19 over 27. Let me check. Negative 24. Multiply this by 3. Negative 24. So that will be 16. Negative 16 over 27 equal to negative 2a. So our a is positive 8 over 27. Alright? So our integral becomes a 8 over 27 over x minus 1. B is negative 4 over 9 over x minus 1 squared. Then C is negative 8 over 27 over x plus 2. And D 5 over 9 over x plus 2 squared quantity dx. For these two, 8 over 27 over x minus 1 and 8 over 27 or x plus 2, that will yield the ln function. So 8 over 27 ln of absolute value of x minus 1. While for the other two, we shall use here the power formula. Okay, so that will be negative 4 over 9, x minus 1 to the negative 2 plus 1 is negative 1 over negative 1. Then, negative 8 over 27, dx over x plus 2 is ln absolute value of x plus 2 plus 5 over 9. X plus 2 to the negative 2 becomes x plus 2 to the negative 1 over negative 1 plus c. So we combine the first and the third as 1 ln and factoring 8 over 27. So ln of x minus 1 over x plus 2. Because ln of x plus 2 is preceded by a negative sign. So it should be the quotient. Then positive. Negative 4 over 9 over negative 1 is positive 4 over 9 x minus 1. And the other one is negative 5 over 9 over x plus 2 plus c. So that is our final answer. We go to the third. The integral of y squared plus 3 dy over y squared 2y minus 1 squared. Okay, so once again, we have to isolate our integrand y squared plus 3 over y squared 2y minus 1 squared. We have two linear factors, y and 2y minus 1, and both of them are repeated. So a over y plus b over y squared. Y squared will correspond to two partial fractions, a over y and b over y squared. Basically, it is y, linear, and repeated twice, plus c over 2y minus 1 plus d over 2y minus 1 squared. Okay? So this will become ay 2y minus 1 squared plus b 2y minus 1 squared plus c y squared 2y minus 1 and b y squared. Okay? ay 2y minus 1 squared, b 2y minus 1 squared, cy squared 2y minus 1, dy squared equal to y squared plus 3. Okay? So you solve for a, b, c, and d. Now, these are supposed to be the values, so you just verify. Your a will be equal to 12, b is 3, c is negative 24, and d is 13. So you verify. Alright? So going back to our integral, it becomes the integral of 12 over y plus b 3 over y squared minus 24 over 2y minus 1 plus 13 over 2y minus 1 squared quantity dy. So 12 over y dy gives us 12 ln absolute value of y. And 3 over y squared by our formula is y to the negative 1 over negative 1 minus 24. The integral of dy over 2y minus y, 2y minus 1 is 1 half. Because of 2y minus 1, the derivative is 2. So 1 half, and then ln of absolute value of 2y minus 1 plus the last integral dy over 2y minus 1 quantity squared by power formula is 13 times 1 half, again because of the derivative of 2y minus 1, and 2y minus 1 to the negative 2 becomes 2y minus 1 to the negative 1 over negative 1 plus c. So 24 over 2 is 12. We can combine the two ln's, factoring first the constant 12, then ln of y minus ln of 2y minus 1 will be equivalent to the ln of the quotient y over 2y minus 1. Okay, and then what else do we have? Negative 3 over y. Negative 3 over y, and the other one is negative 13 over 2, 2y minus 1 plus 6. Okay, you evaluate. You evaluate the integral of 2x squared minus 3 all over x squared minus 4x minus 5 times x squared plus 4x plus 4 quantity x.